Howdy! In this video, we're going to go ahead and combine two rational expressions via the operation of subtraction. We already did a video involving the subtraction of two rational expressions, but that was the case where the denominators were equal to each other, or in other words, they already had a common denominator. Notice in this case that the denominators of each of the rational expressions are algebraically unequal to each other. I mean, they both involve x. However, what we're doing to x is different in each case, so therefore the denominators are not equal to each other. But that doesn't mean that we can't combine the two rational expressions. What it ultimately means for us is that we have to apply what's called the LCM method. So over here off to the right, what we're going to do is construct what's called an LCM, in other words, the least common multiple of the denominators. So the least common multiple is basically an expression that each of the denominators should divide on their own. So if we look at the first denominator of x minus 4, in order for x minus 4 to divide the LCM is going to need to have the factor of x minus 4. If we look at the second denominator of the rational expressions here, in order for x plus 3 to divide the LCM is going to need to have, you guessed it, the factor of x plus 3. So notice I'm multiplying the two LCMs together. This guarantees that if we wanted to see concretely whether or not the denominators did divide it, we would just stick the LCM on top of each denominator and you'd see that things would cancel out. In a kind of stated differently, the LCM when the denominators are not equal to each other is simply their product. So that's another way of constructing the LCM. So the next thing that you're probably wondering is how do we utilize the LCM? Well, here's what we're going to do. We're going to take our rational expression. Let me just write it out again. 3x over x minus 4 minus x over x plus 3. And what we'll have to do is rewrite each of these rational expressions so that the denominators look like the LCM. If we look at the first denominator, x minus 4, that's only part of the LCM. If I wanted it to look like the full LCM, I'd need to involve the factor of x plus 3. And you're allowed to put the factor of x plus 3 down there, provided that you multiply the top of this rational expression by x plus 3 as well. Now similarly with the second rational expression, we'll multiply the denominator by the factor of x minus 4 because that's what was missing from the LCM, but of course we'll have to do it on top as well. Now things are going to just kind of clean up and become business as usual. So what we're going to do next is distribute the 3x that's on top of the first rational expression to clear parentheses, and that gives us 3x squared plus 9x all over, and I'll write out the LCM as x minus 4 quantity x plus 3. Do keep in mind we're subtracting, and I'm going to go ahead and distribute the x in to clear parentheses to get x squared minus 4x, and that's going to be on top of a copy of the LCM as well. So now we're in the position where we're subtracting two rational expressions that have a common denominator. So what we'll do next is go ahead and carry out the subtraction by subtracting the numerators. So we're going to take 3x squared plus 9x. And since we're subtracting a numerator with two terms, I'm going to use parentheses. So subtract x squared minus 4x, put that in parentheses. And I'm going to write all this on one copy of the common denominator, x minus 4 times x plus 3. So we can go a little bit further with the top by clearing parentheses via distribution of the negative there. And what we'll have next is 3x squared plus 9x minus x squared plus 4x. All over, you guessed it, the LCM, x minus 4 times x plus 3. All right, let's clean up that numerator a little bit more. Looks like we have a couple of like terms here. For instance, 3x squared minus x squared gives us 2x squared, and 9x plus 4x gives us positive 13x. All over x minus 4 times x plus 3. There's actually one more thing that we can do, and that has to do with the numerator again. And what we're going to do is actually factor out a GCF. Notice 2x squared plus 13x has a GCF of x, so I'd like to take that out, factor it out, and we're left over with 2x plus 13 all over x minus 4 times x plus 3. Alright, last thing you want to check for is whether or not there are any matching factors between top and bottom, in which case the rational expression would reduce to lowest terms. But clearly we don't have any of that going on. Everything is completely factored, combined into a single rational expression. So all in all, what that ultimately means is that we are finished. Alright, I'll go ahead and cloud this in, and of course if you have any questions whatsoever about the video, feel free to let me know. Otherwise, thanks for watching, and I'll see you in the next one.